Well, good day, Matrix. Welcome to online learning. I have my handy assistant and director, Amran. Amran, show them who you are and wave, please. Right. She's helping us in using the best of modern technology. Right, pause. These are your notes that are going to have you on the board. You're going to have to pause, write them into your book, whatever you have to do. Okay. So this, by the way, is part of calculus, and it falls under paper 1. And it's what we're going to be doing for the next few weeks. Okay. How am I looking? Okay. Oh, we've got props. Hang on. Right. So, this is to help us in case Corona falls on our heads. Okay, so the first thing what you're looking at today is the concept of a limit. Okay. And this is don't ever quote this definition, this is my definition, but the way I think about it is a limit is concerned about where we're going to and not whether we get there. Okay, it's only worried about where we're heading towards and not whether we get there. So, over here, I've drawn a straight line. It's a function, we've called it f. Okay? And in this function over here, there is a microscopic hole in the graph at x is equal to 2. Okay, you don't have to worry about it in core maths, but it's something called a removable discontinuity. Okay, in fact, if you drew this on a computer, the computer wouldn't pick it up. Okay? So, if I have a look over here, okay, and I said to you, what is the limit of f of x as x tends to 2? And the way I think about it is, if I have two cockroaches, they say head towards 2 and head towards 2 from the left and the right. So I'm heading towards the cockroach, the one head is heading towards from the left and the heading from the right. Okay? And what do the cockroaches think? What is a limit value is a y value. They think this cockroach and this cockroach think they're going to get to a y value of 4. Okay? They can get infinitely close to x is equal to 2, but at the last second, okay, can you just act interested in this interestingness? At the last second, what happens? They get sucked out, okay, and they never actually get to 2. But a limit doesn't care about that. So on graph f, the limit, this is a subscript, the x tends to 2. It's written like this, x tends to 2. The limit, then underneath of x tends to 2 of what graph you're working on. In this case, it was f of x, right? So the limit, it's ridiculous, as x tends to 2 of f of x. Well, where do the cockroaches think they're going to get? What y value? They think they're going to get to a y value of 4. Okay? However, f of 2, so the limit is 4, even though it doesn't get to 4, the limit of x tends to 2 is 4. However, f of 2 itself, is there a y value x is equal to 2, Amran?
I don't know.
No, there's not. There's a hole in the graph. Okay? So f of 2 does not exist. So there's a limit at x is equal to 2, but there's no y value at x is equal to 2. There's this microscopic hole in the graph. Okay? Right. If I look at this, what is the limit on graph f? So I'm working on graph f as x tends to 1. Well, if we look at our cockroaches again, okay, the cockroach approaching x is equal to 1 from the left, and the cockroach heading towards x is equal to 1 from the right. On graph f, okay, the cockroaches think they're going to get to a y value of 3. Okay. The limit as x tends to 1, she's going to go onto her phone. Okay. As x tends to 1 of f of x is equal to 3. Okay. In this case, there's not a gap in the graph. It's just a continuous curve. So f of 1 is 3. We say that the limit value is the same thing as the y value. Okay. Right. So get that down. Right. And I want you to have a look at this example over here. Okay. And in this example here, basically I've got the parabola f of x is x squared plus 1, and I've got a hole in the graph. So once again, there's a tiny hole in the graph, But now there's a difference. This hole, the way I can think about it, is this point of the graph has been sucked out and shoved back down here. Okay? So the point on the graph is negative 1, 1. Okay? Right? And this is the point 2, 5. There's a hole in the graph, but negative 1, 1 is a point on the graph. So the graph is made up of that parabola and a point. So, I want you to try, press pause on the video, okay, get these questions down, okay, and try answer them, okay, and come back once you've tried the video, once you've tried them. Okay, I'm on the other hand, I'm carrying on. You should be trying these sums. So, here are your solutions to which you've diligently tried. Okay, no doubt you're all sitting at your desks, working and writing, not lying on your bed, okay, and WhatsApping at the same time. What good girls you are. So, first question, what is the limit as x tends to negative 1 of g of x? So g is that curve and that point. So as a cockroach heads towards an x value of negative 1 from the left and the right on the curve, okay.
I think you drank my freezer.
We'll worry about that later. What y value do you think you're getting to? Did I drink yours? Okay, well, let's get back to this. As x heads towards negative 1, your y value is heading towards 2. So the limit as x tends to negative 1 on graph g is equal to 2. Both of these cockroaches think they're going to get to 2. Okay. G of negative 1, however, means what is the y value when x is negative 1? Well, when x is negative 1, there's the point. Oh, ma'am. Okay, when x is negative 1, okay, y is going to be equal to 1. Do you agree, Amber?
Yes.
Good. Why? Because I am?
Roger.
Amazing. Right, okay. Now, the limit is x tends to 2 of g of x. The limit means where we concern as x heads towards, as the cockroaches head towards 2 from the left and the right. And when you're filming, come on. Okay. As x tends towards 2 from the left and the right, the y value you think they're going to get to? 5. So that's 5. And in this case, it should be g of 2. Okay. G of 2. Okay, what does that mean? The y value when x is equal to 2 on curve g, and it's the same thing. So your limit value there is the same thing as your y value. We're going to stop. I have a little pause, Amber. Say 1, 2, 3. Right. We are back. You don't even know we were gone because we pressed pause. We are technologically savvy. But we have managed to finish our drink. Amber is back. She's also finished hers, I think. Has she? Nearly. Normally she saves things so that she makes me suffer afterwards. Right, we're still carrying on with finding limits graphically. So I gave you a function, h of x is equal to 2 over x minus 2. And all of you at this point want to say, oh, we know what that is. That is a hyperbola. Okay. And it's a hyperbola with a vertical asymptote where? At x is equal to 2. So roughly speaking, we've got a hyperbola